Hello all. In this video, we're going to take a closer look at debugging. So now that you've started programming, as soon as you start writing programs, the very next thing you have to do is to debug them. There's a lot to learn about debugging. This is a complex skill. In order to be able to figure out what's wrong with a program, you need to have a deep understanding of what that program is doing and of the kinds of errors that could happen. And you need some good strategies for testing and finding those errors. So we're going to start a long-term conversation about those issues here today. First, I'm going to show you some notes I have with some good advice, and then we'll work through an example together. All right, so here are my notes for this topic. So what is debugging? Debugging is a bug is considered an error in your code. It's something that causes the program not to work correctly or to produce the wrong answer. And it's basically a result, as we've mentioned before, of the fact that humans are not very good with the kind of precision that computers need to be sure that they are accurately producing what we've asked them to do. So we spend a lot of time fixing bugs. And I think I quote somewhere else a statistic that says that software engineers traditionally spend about 10% of their time writing new code and the remainder of their time fixing their code. So it is a big issue. It is a major skill that you need to master, and it is certainly a skill that you need to have mastered even if you intend eventually to let AI do some code generation for you. You still need to be able to assess, test, and debug code that is produced by an AI system. So here I have some advice for you on how you can go about minimizing your frustration with debugging. If you don't follow these rules, then you often will find that debugging just takes forever and it becomes very frustrating and you can get stuck. So my first piece of advice is to be systematic. This means planning ahead what it is that you want to do with your code. This makes sure that you know what the code is supposed to do at every step so that you can check every step. You want to be sure you understand which steps you are going to implement first, and you want to think through a set of examples that you want to test your program on to ensure that you're testing it thoroughly and covering as many situations as possible. You also want to make sure that you know what should be happening at each step for each of those examples so that you can step through your program and watch what it's doing and make sense of every step along the way. You also want to make sure that you don't just copy code, even from like a class example or something you wrote earlier. Don't just copy code without being sure that you understand exactly what its purpose is. You may find that the purpose it had in some other program needs to be modified to fit your current program, and if you don't think that through, you can end up with code that you assume is correct because it worked in another context, but it is not correct for your context. Another one that's brought up in your reading, and we're going to keep trying to reinforce this as good practice, is this idea of incremental development. So instead of trying, we say plan out your whole program maybe ahead of time. But when you actually go to implement it, do not just write it all into code before you start testing. That does not work. Because you have multiple bugs in multiple places, it becomes very difficult to isolate any one bug. Incremental development says when you have a plan for what you want to implement, you implement the first step or two, and then you test it. Are those doing what you expect? Are you getting the expected results? How does it look so far? That might mean adding print statements. We'll also teach you eventually to use the debugger that comes with PyCharm, and you can use that. But adding print statements even is an excellent way of checking what the program is doing at each step. You use lots and lots of tests, and once you're sure that the first few lines work for what you've tested, then you go on and add the next few lines. This is an ongoing process, and sometimes you have to go back because there may be a bug that you didn't test and catch initially. Thorough testing is the last piece of advice. don't just have one example that you test your program on, because it probably doesn't cover all possible situations. Think through what those situations are, plan a set of tests, and think about particularly boundary conditions. So these are places where the behavior changes, maybe because you're at, say, the ends of a list, or there's some circumstance with an if statement that's going to, with a conditional that's going to cause it to behave differently. Positive versus negative numbers. Think about those boundary conditions and test the values around the boundary particularly to make sure that they behave properly. All right, I have some additional tips. Some of these are more not strategies for implementing, but sort of debugging tips. One of the things that happens early on, and it's inevitable, I think, is we are convinced that what we've written is correct, and we say, well, it's not working, so something's wrong with Python. What are the chances that something's wrong with Python? 1 in a million, maybe more. 1 in a billion. Don't blame Python. If something in your program is not working correctly, it's because you haven't communicated what you want to have Python do clearly enough, accurately enough. Or you have a misunderstanding about exactly what's happening that is getting in the way. Read error messages carefully. When the program crashes and you get an error message, pay attention to where that error message is happening and read what it says, because it's trying to give you helpful information. They're not always easy to read, and sometimes you may need to get help understanding what is happening with an error message. But read it carefully and pay attention to what it's trying to tell you. Adding print statements, I already mentioned. Another thing that can happen if you really just can't figure out where the bug is coming from is comment out code. Like, comment out your whole program and make sure that the bug goes away. And then start adding lines back a few at a time until the bug resurfaces. Because then it lets you narrow right down to a few lines that are causing the problem. All right, we're going to take a look at a number of different errors. These were all discussed in the readings. So parse errors or syntax errors, which term shows up depends on what version of Python you're using. These are errors in your syntax. So this is where you have not written proper scheme or proper Python, and it is fussing about that. This is something that you can often detect in the editor. We're using a sophisticated IDE. It can detect syntax errors and mark them for you. So you want to check for those before you even try to run your program. If you get a syntax error, the nice thing is that it's going to mark where it found the error. You just have to be aware that sometimes the actual error could be above that point, some number of lines. And the program did its best to interpret what was happening until it couldn't anymore. So you can't always find the line that the error is on for certain, but you can find lines that seem suspicious by looking above. There are other errors here, 3 others that are listed. Type error is when you try to apply an operation to a data type that it doesn't work for. So for instance, trying to use the subtraction operator with a string, or the length operator, len, with a number, or something like that. A name error, this usually means that you've got a variable name misspelled. That's like 90% of the name errors you are going to receive are because you have misspelled a variable name. But it means typically that there's a variable name that you're referring to that Python doesn't know about. It hasn't been defined yet, and you're using it. Why does that happen? Usually a typo. So look for that. Value error. This is what happens when you pass a function a value it can't work with. So it's similar to a type error, but type errors tend to happen with operations, and value errors tend to happen more often with functions. So, if you tried to pass one of our type conversion functions, something it can't work with, then you might get a value error. All right, now what we're going to do is to take an example. I have a problem in mind, and I'm going to shift over so I can pull up our editor. There, so now I'm in desktop view, and I'm going to pull up our editor. And I'm going to write out the steps ahead of time. I'm going to plan ahead, write some pseudocode. And then I'll start implementing it and testing it. And we'll kind of demonstrate this whole process. Along the way, there will definitely be error messages that I will generate, even if I have to do it by hand. First of all, these to-do messages, these are special kinds of comments in your code that indicate what you're supposed to do. And when you finish doing them, then you can delete those to-dos from your file. And notice that over here on the right, to-do messages show up in blue. There also were some other things showing up. PyCharm is a little fussed with me because I have extra blank lines that it doesn't like. So we're going to ignore that. But you notice there's nothing over here that's bright yellow or red. So there's nothing that Python thinks is an actual error at this point. All right, so I'm going to write a comment. And I'm just going to write out the pseudocode for what I want to do. So what the to-do says is write a script that shows a user a string, and then let them specify the start and the end indices. So that's the indexing of a string. It starts with 0 and it goes up from there. And what we want is then to slice out the substring that the user has specified and print it for them. This is a fairly simple task. So step number 1, define the string in a variable. I could just show it to the user, but I know if I'm going to want to do string slicing, I better have it stored. So I'm going to store it in a variable. Oh, that needs to be part of a comment. 2, print the string for the user. Step 3, ask user to input the starting index. Step 4, ask user to input the ending index. Step 5, get the substring with slicing. We just started talking about slicing, so try to remember how it works. I'll show it to you when we get to the code. And finally, print the substring. Okay, so those are the steps that we want. Each of those may, in this case, each of those may correspond more or less to a single line. So what we're going to do is to actually start implementing these steps. So string equals this is one of my favorite strings. When I just not want a nonsense string that isn't complete nonsense, I often use this one. This is actually a palindrome. If you take out the spacing and the capitalization and the punctuation, it is the same written backwards as forwards. And it's a meaningful palindrome because this is a reference to a person. A man, a plan, a canal, Panama. Who the person is, it's usually interpreted as Theodore Roosevelt because he was the primary motive force in the U.S. for funding the Panama Canal, but you could also have it be the designer or designers of the Panama Canal. But I'm going to print the string. Okay, so if I were doing incremental development, what I might do at this point is to pause and say, okay, I've implemented 2 lines. Let's run this. And it prints a man, a plan, a canal, Panama. That's what we want. So far, this seems okay. And we're going to keep going. Now, do you remember how you get information from a user in a script? You use the input function, and you can type a string inside that function that is the prompt that will be shown to the user, and then whatever the user types is the value returned. So I'm going to say start equals input of enter the starting index. I always like to do a colon and a space there because it looks nicer when you run this. And then enter the ending index. And now this is incremental development. I want to pause. This isn't something that's in my original script. I'm going to add a print statement here just so I can take a look at what start and end actually look like. But I want to show you, I want to demonstrate something for you right now, which is what happens if I put in syntax errors. So typical syntax error here could be something as innocuous as hitting a spacebar at the beginning of a line, or leaving off a close paren, or leaving off a quotation mark. Even worse would be if I left off the front one. What I want you to notice is PyCharm is very unhappy with us now. I've put in some syntax errors and they show up over here on the right. The first one says end of statement expected. So it has a quotation mark and then a new line and a return character. It doesn't like that at all. So it's unhappy with everything that's going on here. It's unhappy at this lower line. It's statement expected found dedent. Unexpected indent. Unexpected indent is what you really want to read. Oh, there's an indentation here that doesn't make sense. Okay, I can fix that one. Here, you can tell from the little squiggly lines there's something wrong with this line. You could try to see if it could identify the problem a little bit better. It's saying end of statement reached, missing close quote, statement expected found bad character, unresolved reference, a Panama, a man, a plan. Statement seems to have no effect. It's just really confused by this line. If we put the quotation mark back, then all of that goes away. And then this one at the bottom, it says comma or close paren expected. So watch for those. Watch for the red lines along the right. Watch for the highlighting in the code to see if you have syntax errors. I'm going to leave one syntax error in here. I'm actually going to take this comma out. It doesn't entirely mark this in red, but it marks it as a problem. And then I'm going to run it. So this is what you get over down here at the bottom. You can see what we get when we run a file that has a syntax error. It says syntax error, invalid syntax, perhaps you forgot a comma. And it's going to print the line above that, print the line that was the problem, and it's highlighting the region where the problem occurred. It actually is giving you really good advice. Maybe you forgot a comma somewhere in here, and then if you remember that things should be comma separated, you can add it back in. All right, let's run it one more time. A man, a plan, a canal. Enter the starting index. It's waiting for me. I'm going to say 5, and then I'm going to say 8. And it prints 5 and 8. Everything looks great. So far, so good. Let's go on to the next step. Get the substring with slicing. So I'm going to have a variable called substr. And if you remember how slicing works, we have square brackets, and then we put the start index, colon, the end index. I'm going to do end plus 1 here because I didn't ask them to give the index 1 past the end of the substring, so I'm going to add 1 for them because that's the way the slicing operator expects. It expects to not include the second number that you give it, the second position. And in this case, the user might have wanted us to. Now notice, I added another syntax error here. It doesn't like this. I mean, this isn't actually a syntax error. This is just an error that PyCharm can pick up for us. I'm going to leave it in there because I want to get an error message for this one. Print your substring. Oops, I don't like that. Is substr. Okay. That should be our whole program. So I'm going to try running it. We'll see what happens. And you can tell from the fact that there's a little red thing here, it's probably not going to work. 5 and 9. Okay. I got a syntax error. And the error is one of our types. It's a name error. If you remember, a name error is when you refer to a variable or a function name and it can't find anything that matches. Often that's because of a typo or because you're using something before it was created. So in this case, the name string is not defined. Did you mean string? That's actually really good. A really good error message because I did mean string. Okay, so I'm going to fix that. Now we've seen syntax errors and name errors. We still have to work on type errors and value errors, but I'll find a way to show you those. So let's try a different set of indices. I got an error message. What did I get? I got a type error. Start colon end plus 1. It's unhappy with the plus operator. That's what generated the type error. And the type error says can only concatenate stir, not int, to stir. Now, I typed a number, and it thinks that either the end or the 1 is a string, so it has to be end that it thinks is a string. And I would be very confused by this, because it looks a little weird to me. So what I'm going to do, what you do when this happens, is you go back here. This is the line that has the problem. Right before that, I'm going to add another print statement. I printed start and end, and they looked okay in the earlier example. I'm going to print them again, just for fun. But I'm also going to print type of start and type of end, because this is a type error. So figuring out exactly what type of data we have is also important. So let's run this and see what it says. 3, 6. All right, here's my output line, the print statement that I just added. And sure enough, start and end are strings. They are not numbers. And we need to have numbers when we do the slicing. So the slicing is not going to work with strings. The plus is not going to work with a string and a number. It doesn't know how to make sense of that. Why is that happening? Well, this is where you might have to do a little digging if you didn't know. But I'll tell you what the bug is. In this case, input always returns a string. The input function returns a string, which is what the user typed. We have to then convert that string into being the type that we actually want. So I'm going to actually go back up here to my pseudocode, because I missed some steps here. Convert user input to an integer. And then I'm going to have to renumber. Convert user input to an integer. I didn't remember to do this, but it is a part that I should do. You can do this all in one line. I'm going to break it up into 2 lines, because I think at this point it's easier for more of you to understand if I don't. So stInd equals int of start. That's all we have to do. And then we're going to have why is it still fussing about this? It's not quite sure what's going on here. All right, and then what I'll do is an end. We'll double check this. While we've got this here, we might as well keep this long enough to make sure we've done that what we've done has worked. And then down here we'll change start and end to be stEnd and enend, stInd and enend. And then we'll see what happens. So try running it again. Aha! Class int now, because we did the conversion. Your substring is an ah. Well, it's not the most lovely or useful of substrings, but it is what I asked for. And I'll double check that it is what I asked for. So what I'm going to try to do now is to get the word man out of here. 0, 1, 2. M starts at 2, so that's the starting index. 3, 4, it goes to the ending index. Your substring is man. We have a working program now. We've also seen type errors, name errors, and syntax errors. We still have the value error. There are different ways that value errors can come about. I'm going to show you one. But in the meantime, I'm going to take out this extra print statement we added, because that isn't part of what we want to do. Okay, so I'm going to run this again. Suppose I'm foolish and I say 3.5 for the starting index. Now notice it crashed before it even got to asking me the second. 3.5, when I try to convert that to an int, I get a value error. Invalid literal for int with base 10, 3.5. 3.5 is not a floating point number that looks like an integer. It is just a totally non-integer value, and we can't convert it. We would have to round it and then convert it if we wanted to do that. Since it's starting out as a string, we're kind of stuck. This is not a value error that I'm going to ask you to fix right now because it's actually a little complicated to recognize that it's a value error, that there's a problem here. So we're just going to, for now, let it be on the user if they type in something that isn't an integer when we've asked them for an index. All right, so now you've seen a demonstration of multiple different errors, and you've seen a little bit of how you do incremental development and some debugging, and hopefully that will be helpful to you. You are going to need to spend a lot of time practicing debugging. And I want to encourage you again, we've talked before about using artificial intelligence. Don't just take a hunk of code that's not working and feed it into an AI and say, what's wrong with this? For one thing, you aren't sure it's going to give you the right answer. And also, you won't learn anything by having it tell you. You need to work out what's wrong. But if you do need a little help from instructor, from preceptor, even from AI or a peer with things like understanding error messages, then that's okay. I would also encourage you to look for tutorials about how to read traceback messages rather than just asking an AI to read it for you. But I do understand that you could put the text of an error message in and say, what is this trying to say? And maybe it would be able to give you something helpful. But also bring those to your instructor and your preceptors because that's what they're there for. All right, we are going to look at some other things in other videos, but we will keep coming back to debugging and adding to your toolkit as your skills as a programmer develop. So I will see you soon.